Image formation by concave mirrors. The method of locating the image produced by a concave mirror consists of drawing light rays emanating from key points on the object and finding where these rays are brought to a focus by the mirror. This task can be accomplished using just 4 simple rules. An incident ray which is parallel to the principal axis is reflected through the focus F of the mirror. An incident ray which passes through the focus F of the mirror is reflected parallel to the principal axis. An incident ray which passes through the center of curvature C of the mirror is reflected back along its own path, since it is normally incident on the mirror. An incident ray which strikes the mirror at its vertex V is reflected such that its angle of incidence with respect to the principal axis is equal to its angle of reflection. Consider an object ST which is placed at a distance P from a concave spherical mirror. For the sake of definiteness, let us suppose that the object distance P is greater than the focal length F of the mirror. Each point on the object is assumed to radiate light rays in all directions. Consider 4 light rays emanating from the tip T of the object, which strike the mirror, as shown in the figure. It can be seen that the reflected rays all come together at some point T1. Thus, T1 is the image of T. As is easily demonstrated, rays emanating from other parts of the object are brought into focus in the vicinity of T1 such that a complete image of the object is produced between S1 and T1. This image could be viewed by projecting it onto a screen placed between points S1 and T1. Such an image is termed a real image. According to the figure, the image is inverted with respect to the object and is also magnified. This figure shows what happens when the object distance P is less than the focal length F. In this case, the image appears to an observer looking straight at the mirror to be located behind the mirror. For instance, rays emanating from the tip T of the object appear, after reflection from the mirror, to come from a point T1 which is behind the mirror. Of course, the image behind the mirror cannot be viewed by projecting it onto a screen because there are no real light rays behind the mirror. This type of image is termed a virtual image. The characteristic difference between a real image and a virtual image is that immediately after reflection from the mirror, light rays emitted by the object converge on a real image, but diverge from a virtual image. According to figure, the image is upright with respect to the object and is also magnified.